and welcome to hear about 3D printing. Today's topic is slicing and slicer settings. Well, what is slicing? Slicing was the step in the 3D printing process in which you create the toolpaths for the 3D printer. You give the slicer software the 3D model of your object, and it will generate the toolpath for the 3D printer itself, where it has to move and extrude how much material, when we're talking about FDM 3D printers. In this talk, we will talk mostly on FDM 3D printers and their slicers. Slicing softwares. We'll go through a few of them. There are like dozen different softwares available. Some cost some money, some are free, but we will go through only a few in this session. First of all, there's a software called Cura, which is free. It works with all the printer types, so it works with a Delta 3D printer, it works with an Cartesian type 3D printer, and it works with a Core XY 3D printer. It has a lot of pre-installed profiles available, so there's a listing for all of the profiles that are installed in the software. But of course, you can add your own profile or someone else's profile who has shared their profile over the internet. And it has a very large selection of different settings. There's like 3 to 4 pages of settings. On the right hand corner in the image, you can see a quick glimpse on the available settings. But you can also see all of the settings listed here. So there's quite a few. Then there's software called Prusa Slicer, which is based on an older slicer called Slick3R, which is also called a slicer. But this is a development by Prusa Research, who built on top of the Slick3R. This one is also free. It works again with all the printer types. And there's a lot of, well, I wouldn't say a lot, like a lot, as many as in Cura, but there's quite a lot, quite big amount of pre-installed profiles in the software nowadays. If we talk about in the beginning of 2020, there weren't any pre-made profiles in this software, so you had to create your own or use someone else's profile that they had created and shared over the internet. In this software, there's also a large selection of different settings that you can set up, and they are developing this software every 2 to 3 months. They're releasing some kind of patch or update on it. Same thing goes for Cura. They are creating newer and newer versions, and updates are coming like in 2 to 3 months. These are two of the biggest and more widely used slicing softwares, which are free. Then there's the third player, Simplify 3D. This was the go-to software back in the day, like 4 to 5 years ago, or 3 to 5 years ago. This is one of the few slicers that cost money. So it costs around 150 euros to use, but that's one-time payment. Again, this works with all the printer types. This has the biggest amount of pre-installed profiles available after installation of the software. Again, a large selection of settings in this software too. And this was one of the few softwares that had the possibility to select, put 10 to 20 objects on the build plate of the printer. Well, every software can do that, but you could adjust each of their parameters. So you could put that for the 5 first cubes, they will be full cubes. So their infill percentages will be 100%. And like next 5 will be 10%, and so on and so on. You could select for each and every model that is in the build plate, you could select these settings. So those were pretty much the slicers. In a quick glance, the biggest 3 ones. So those were the slicers, which are the most known slicers. Then we can go on to the settings. So slicer settings, there's a lot of these, but we will go through on the most important ones. First, there's layer height. This is a major setting because this affects the quality and the print speed of the object, because this determines how many the layers that the printer will lay the plastic will be. This means that if you have a 10 millimeter high object, and if you use layer height 0.2 millimeters, you will end up with 50 layers. But if you use 0.10 millimeter layers, you will end up with 100 layers. And it's pretty much the same time that it takes to run a one layer for this 0.1 or 0.2. Thus, it takes more time. As you can see in the image, there's one object that has been printed with 3 different settings. On the left, the layer height is 0.2 millimeters, and the print took 1 hour and 50 minutes. And in the middle, the layer height is 0.1 millimeter, and the print took 3 hours and 45 minutes. So there's almost 2-hour difference in this print time. And it's the same model. But in the softwares nowadays, there's a possibility to use variable layer height. So you can adjust where do you want the more precise layer height to be, and which parts of the object can be printed with draft layers, which means that they will be bigger, but they won't have any details, so it doesn't matter. So you can adjust and then optimize the print time. As you can see, the time dropped to 2 hours and 20 minutes. So that's quite significant boost to the time if you're in a hurry. And most common layer height is 0.15 millimeters. And again, this layer height can vary from 0.05 to 0.5 millimeters or even 1 millimeter. This also depends on the nozzle that is being used. The rule of thumb is that mostly you should run your printer with half of your nozzle size. So if you use a nozzle which is 0.4 millimeter diameter, you should use 0.2 millimeter layer heights. And if you use a nozzle of 0.6 millimeters, you should use a layer height of 0.3. That's the rough estimate. But of course, 0.15 is a bit more detailed than 0.2. Again, this depends on the person's own preference. Then the other significant settings again, the infill. The infill determines the percentage amount of inner supports inside the print. You can see in the upper image, there's 5 cubes and each of them has different amount of infill. In the first one, there's like 5%, second one is 10, then it's 15, then it's 30, and then it's 50. So the more percent it has, the more it will be filled. So this affects the weight of the piece and also the strength. And obviously the print time. And then there's the infill types in the image below. There's the rectilinear, there's the honeycomb, there's the cubic, there's gyroid, triangles, and grid. Different type of infills which have a bit different strengths. Triangles is a fast infill method to print because it's basically a straight line. And then there's the gyroid and cubic, which are like 3-dimensional infills, which give more support and more strength to the part. And then there's the rectilinear and grid. And then there's the honeycomb pattern. This also affects, again, the strength of the part. Most usual one is the triangles or the gyroid or rectilinear. Those 3 are the most common ones that programs themselves use as default values. So, perimeters and wall thickness. Just now we were explaining about the infill, and now we talk about the walls. You can see in the image there's like these yellow outlines for these cubes. You can see the yellow lines in the image. Those are the perimeters of the part. With the perimeter settings, you can select how many perimeters will be in the print. The more you put, you will have a thicker wall inside the part. And thicker wall or more perimeters means again more durability or strength for the part. Again, also it means more weight for the part and more print time. So this is basically a bigger meaning than infill because it affects the surfaces the outer surfaces of the part. So if you are willing to sand, for example, the part after printing, you should use more than 2 perimeter walls, because then you will have room to use a sandpaper to smoothen the surface. There will be more material to be sanded, so you won't see the infill straight ahead if you use the sandpaper a little bit. And if you have more walls, then there's this effect called ringing, which shouldn't happen. If you don't have enough walls in your print, you will have a lot of ringing in the parts, or this salmon type of pattern on the walls of the part, which doesn't look good. In slicer softwares, the common setting is usually 2 perimeters, but if you need a part which has more strength, you should use more than 2 walls. Some slicers have the perimeter setting and some slicers have the wall thickness setting. For example, Cura has both, which you can use the other one and then it blocks the other setting. So if you select that you will use 3 perimeters, then it will block your wall thickness setting. But if you adjust the perimeter setting to default, you can then adjust the wall thickness. It's basically the same thing, but with different words. Then there's the top and bottom solid layers. In the image you can see the worst case scenarios, that if you have too few top layers, the print will look like that. The infill inside will push through, or in the left image you can see that the infill of the part will push through, and in the right image you can see that there's not enough infill, so that top part of the print will be fully completed. So it will have these holes. They again affect the strength of the part and really the quality, the surface quality. Then there's the support setting. Supports are created when a surface is in the middle of the air and there's nothing below it, or supports are created when the angle is above 45 degrees. So in the left image, there's a setting called use supports on build plate. So it will create only supports on the part where it hovers over the build plate. So you can see that there's no supports in the middle of the part. On the right image, the settings everywhere was used. So it will place supports everywhere where the angle is over 45 degrees. So even though there's like parts underneath, it will place supports there to support the piece so it doesn't fall. Support should be used every time there's stuff that hangs in the air. You can always check the supports if they are needed. Sometimes your 3D printer can manage curves over 45 degrees. Some can even handle even 70 degrees ones, but that's really depending on the printer. You should test out what is the capability of your 3D printer. Then there's the retraction setting. On the left, you can see the image that we don't want to see in our prints that are finished. So if we don't use retraction and we have these tips or places where printer will move between. So we have like 2 different objects on the build plate, and it will print the other one and then move to the other one and start printing there. And when it's finished, it will go to the other one again, and etc. And this effect will happen that it will leave these strings or little pieces of plastic onto the print or in between. With retraction, we can fight back for this. Retraction means that when it starts to move to the other place, the printer will move from one position to the other. Retraction means that it will draw back the material into the extruder, and once it gets there, it will push the material back. Because if we don't draw the material, it will start drooping from the nozzle. Because it's melt plastic. There will be always plastic in the nozzle, and it will always drip. So this sucks the melted plastic from the nozzle back to the extruder and push it back to the nozzle once it reaches the position. So it basically affects how the print looks and how the print will succeed in the end. So you can adjust the speed of the retraction itself and the retraction distance. Then there's adhesion. So for different materials, for example, ABS or BGG, you might have some difficulties with the adhesion of the part to the build plate. There's 3 different things that you can use, at least these 3 things. There's the brim, there's the skirt, and there's the raft. Brim is basically the image on the middle. It basically creates this a skirt that touches the print. So the skirt goes around the part wholly and touches the print. So it will keep it down. If it tries to start warping from one end, it will hold it down a bit more. And the skirt setting is the image below. So there's the part itself, and around it there's empty space, and then 2 centimeters distance from the part, you can see that there goes 3 lines of material. So that's the skirt. So the skirt's idea is basically so that you can make sure that the filament is coming out of the printer, and you can do your final bed leveling adjustments there. And then there's adhesion thing called raft, which lays like a bed full of material to the build plate, so that any uneven things that are on the build plate will be evened out, because it will fill the holes with melted plastic. This helps out with the adhesion quite a lot, but the raft leaves a bit poorer quality bottom surface, so it doesn't look so good. Then there's the print speed. You can adjust each and every setting of the print speed. You can adjust the perimeter setting, you can adjust the infill speeds, you can adjust the bridge speed, you can adjust the travel speed. Everything can be adjusted. You can adjust the accelerations. But basic speeds are the ones around 40 to 60 millimeters a second. Those are the basic speeds that you will get good results. If you turn up the speeds above that, for example 70 to 80 millimeters, you might have some difficulties for the adhesion of the print, or you will have some detail lost. This again depends on how well you have calibrated your 3D printer and how well you know it. Then there's extrusion multiplier or flow rate, which affects how much plastic will be extruded on each movement. Because when a printer moves from one position to other, it also tells the extruder to push out a certain amount of material. For example, if we have a printer head move from position A to position B, and we tell it to extrude material 10 centimeters. If we have extrusion multiplier 1 or flow rate 100%, then it will extrude that 1 centimeter of material on that movement from point A to point B. But if we have an extrusion multiplier 1.1, then it will extrude 11 millimeters of plastic. So it will extrude that 1 millimeter extra material. This setting exists because sometimes materials behave a little bit differently, or their diameters might be a bit off. So you can compensate the extrusion width of your 3D printer with this setting. If you try to print a cube that is 20 millimeters by 20 millimeters by 20 millimeters, and it's like 20.4 or 20.5 millimeters, so that might be a case of the extrusion multiplier value is too high. So you need to calibrate that value. And it should be calibrated for each material for best results. But usually the default settings work. There are some cases on a bit exotic materials that will have to have their extrusion multipliers calibrated. And this is easily done by printing a simple cube with 2 perimeters and then measuring those perimeters thickness. So slicers produce GCode. What is that? Well, it's called GCode, means geometric code. It's developed back in the 1950s for CNC machines. And printers, of course, don't use exactly the same GCode than a CNC machine uses. It uses the same standard but it doesn't use the same things. It does have some extra in it, so the 3D printer GCode has commands for bed heating, extrusion, heating the extruder or the nozzle itself, and stuff like that. The GCode's mission is to tell the machine to work in the 3D dimensional space. It can also be used for giving orders to start extruding or heating the nozzle or heating the build plate. So, how it's read. Here's a simple starting GCode for one print that was done. And you can see that there's like 20 to 30 lines, well, at least 20 lines before the print even starts. It uses these basic settings that it sets to the printer before it even starts the print. How it's really read. The most important part are the G1 codes. So it tells, for example, in this example, there's G1 X102.893, Y64.175, and Z1.0, and F3000, E0.10199. So what this means? So it means that G1 X go to the X position 102, Y64 means go to the Y direction, Y coordinate 64, and Z go to the coordinate 1 millimeter above the build plate. And F determines the speed of the printer that it goes at that coordinate, and E tells the length of the extruded material. And there's like hundreds of different G and M codes that work with a 3D printer, but some printers have different firmwares and those differentiate from each other. I mean, they are different. Not every G-code works with the same firmware. But that was the quick glance on slicer and slicer settings and G-code. Hope you enjoyed it. See you in the next one.